Welcome back to Griffith Observatory, a gorgeous, starry, city light-filled night evening with a beautiful view of Mars right behind us. Right behind us. So close you can almost reach out and touch it, and only about 35.8 million?
You have to have a long arm.
Yeah, that's right. Or a spacecraft, which is what we've done. What an amazing history of Mars exploration we've had. And you've been a part of it for quite some time. Do you want to tell people a little bit about your background? How did you get into this business, and what are some of the projects you've worked on?
Well, I actually am an atmospheric scientist, but Mars has an atmosphere, and so we need Mars meteorologists, just like we do on the Earth. I actually came to JPL when Viking was landing on Mars. A very exciting time. Here was 2 orbiters, 2 landers, deployed from orbit, setting down on the surface for the very first time successfully. And so that was a very exciting time.
And that was a while ago.
Yeah.
Yes,
right.
So you were a young Dr. Rich Zurek.
Yes.
And
it's amazing how fast these years go by. But there was a time when we weren't doing very much at Mars. And
we'll start to get static on this one.
Okay. So there was a time when we were not doing very much at Mars, and that was after the Viking missions, and there were other things to do at the time, but we also thought we needed to get back to the planet. And when we started doing that, we started with the Pathfinder mission, and it had a little rover, and that was the first of our landed things going out, setting down on the planet. It didn't go very far, it sort of did ring around the lander itself.
So how big was Sojourner Rover? Is
about
it about the size of this table?
Box. That's right.
A bread box, so it would fit on this table.
It would indeed.
Oh my goodness.
So a very small thing, and nowadays we fly things that weigh a ton to go out to the planets and sit down, and that's Curiosity now roving across the surface of the planet. We also put down a couple of rovers that were supposed to be just 90-day wonders. We weren't sure if we were going to do this, that we were landing them in airbags, which would deflate, and then the rovers would go out onto the surface, off of the platforms and such, and explore. Well, that was a 90-day mission, and that was 13 years ago for the Opportunity rover.
It's been a long 90 days.
It's been a long 90 days. So I think, although the warranty is up, they kind of outperformed their specs for just how long they might go on the planet. So right now, there's a lot of spacecraft at Mars. We got the 2 rovers on the surface, although Opportunity, as you've noted, is in hibernation right now, waiting for the sky to clear so that we get enough power to call home again once it's charged up its batteries.
Now, what is the prognosis on that? Or is it going to come back to us? Are we? I know everyone's holding their breaths, but what do you think about it?
I'm optimistic, and the reason is that one of the things you need power for is to keep yourself warm. And actually during these dust storms, the nighttime temperatures, which are the coldest, just like on Earth, they're actually warmer because the dust sort of acts as an insulating blanket and keeps the ground a little warmer and such. So what we need is the sky to clear up in a hurry so we can charge up the panels before the temperatures drop again back to what they would be. Fortunately, Mars is getting closer to the sun, although tonight it's closest to the Earth, as it will be for some time. It will get closer to the sun here over the next couple of months. It has a very elliptical orbit, that warms it up a bit. So we're very hopeful that we'll get a call home. That might not come for another month, because it may take that long for the dust to fall out of the atmosphere. This is very fine material that's being lofted up into the sky, and some of it is going up 40 or 50 miles into the sky. So it takes a while for it to fall out from those heights and stuff. But the good news is it looks like the storm is beginning to clear up. We're starting to see some of those classic surface features like Syrtis Major appear through the murk again. But it's still going to take maybe another month or so before Opportunity will have enough power to call home. Mm-hmm. And part of that is we don't know how much dust will fall on the arrays and stick there before it gets blown off. But it's an Endeavour crater, which is one of the windier spots on Mars, so we're hopeful.
I seem to remember there was a time when the solar panels were covered with dust, and a dust devil came by and cleaned them off. Am I remembering that correctly?
You are indeed. There's been several so-called cleaning events. And in fact, just before this dust storm, they were almost back at some of the original power levels back many years ago. Well, the dust storm changed all that, of course. But a lot of that dust is in the atmosphere now, and as it falls out, if we just get a little wind blowing around the rover, it'll keep the arrays clean enough. So we're hopeful.
Great.
I don't want to underplay. It is serious
Yeah.
that when you have a solar-powered mission, this is what can happen.
Yeah.
The sky can get dark for weeks, and now it's going to take another month or maybe 2 for that dust to clear up.
So Curiosity's not suffering really the same fate because it doesn't rely on solar panels.
Nuclear
is that right?
power can be a very helpful thing
Yeah.
on a dusty planet. And that's what we're dealing with on Mars, is that a lot of dust. And these storms, though, don't happen every Mars year. In fact, we've tried to estimate, based upon some of the telescopic observations, like people looking at the planet tonight, just what those are. But because you tend to look, when you're looking with a telescope from Earth, only when Mars is close to Earth, that means you're not watching Mars all the time. And so to change that, we've put orbiters out to the planet, and now they can go around the planet, and they can show us. Each day we can get a daily global map of the entire atmosphere, and that's what the Mars Reconnaissance Orbiter is doing. And even then, it's also taking the temperature of the atmosphere so we can see the effects of the dust as well.
Yeah, we had the slide, if we can just show the slide, of all of the orbiters that are currently, it's a flotilla.
It's a flotilla.
Of spacecraft all around Mars, all operating, working together. And if I'm not mistaken, some are actually acting as relays to help communicate with the ground as well, yeah?
Indeed. The Mars Odyssey spacecraft and the Mars Reconnaissance Orbiter are routinely relaying data from both Curiosity and, when it's sending information, Opportunity. And the other missions, like Maven and the Trace Gas Orbiter, which are newly arrived, they've both been equipped by NASA with devices that can relay those signals back.
Yeah.
And the advantage here is that the orbiters can have great big solar arrays. They're not subject to the dust blowing around in the atmosphere. And so they have plenty of power to send all that data all the way from Mars back to the Earth, so that the rovers only have to send it 180 miles or so up to orbit. And then the orbiters can relay it all the way back to the Earth, which can be from 35 million to well over that when Mars is on the other side of the sun.
How far do we get when we're as far apart? If tonight's the closest approach, what's the farthest distance that we get from Mars?
Well, you add the Earth's orbit, and you double that, because if Earth is on this side of the sun, so that Mars is lined up, but on the far side of the sun, now we're talking about 240 million miles. So it's
8 times farther away.
It's further away.
And it gets very small in a telescope.
And so most people don't look through their telescopes at that time. But with our orbiters, we got the same view every day flying over the planet.
Now, you mentioned Maven, and Maven just had a new result. And can you tell us a little bit about Maven and what its mission is?
Well, each of our orbiters were sort of designed to look at particular aspects of the problem. And I mean, an obvious question is, why are we studying Mars? And one of the things we want to learn is, we think the climate of Mars has changed from a more Earth-like climate very early in its history, literally billions of years ago. And that climate was wetter, the atmosphere was thicker. And so the question is where did that atmosphere go? Because today, that atmosphere is less than 1% of our own atmosphere here on Earth. So where did that atmosphere go? One idea is that very early on, Mars had a magnetic field like the Earth, and that magnetic field sort of holds off the solar wind from sweeping into the atmosphere and accelerating some of the molecules that are in the atmosphere out into space. Mars lost that magnetic field, so the solar wind could dip in, and over billions of years, it stripped away until today's remnant atmosphere maybe only 1/100th of the original atmosphere on the planet. So that's really counts. And yet understanding the process, because what we want to do is we want to extrapolate back over all that time to when Mars might have had this more massive atmosphere. How thick was it? Was it wet? Where did the water go that was probably in that atmosphere? A lot of it has been lost to space. And the other place that the water may go is frozen into the ground today. Unfortunately, liquid water under most Mars conditions today isn't. It's either ice or it's vapor in the atmosphere, because water on Mars acts like CO2 in the Earth. It goes between the solid and the gas phase as temperatures dictate. So Maven has been looking at this process today, and if you take just one set of the molecules that are being stripped away, the sort of charged particles, it's about a quarter pounder a second being stripped away from the planet.
Well, that's an easy way to remember it. That's a visual. If we were at All Space Considered, we'd be having quarter pounders flying off of Mars. We've been talking about the change in Mars's atmosphere and how it can't hold water on the surface anymore. And there's a really fundamental reason why we want to know about this wet earlier time on Mars, and maybe you could say a little bit about that. I mean, we're spending all this effort, we're so anxious to find water on or in Mars, and we'll come to that in a minute, but why is that? What's so important about finding water on Mars?
So finding water, liquid water, any place in the solar system, we think water is essential to life as we know it. It's an agent of climate change. It erodes the surface and rocks and such. And finally, with Mars, it could be a resource for future exploration by people down on the surface of the planet itself. We don't want to haul all that water to Mars if it has its own resources. So if it has ice in the near surface that we could dig up or tap into, that would be great, because then we can change that water into fuel, into oxygen to breathe. It'd be a real resource for us. But our real thing is did life ever develop elsewhere than on the Earth?
Yeah.
Where in the solar system could it be? And Mars is one of those more Earth-like environments, particularly in that early history before its climate changed, where life might have gotten a start, a hold. And so the question is there any evidence in the surface today of that ancient life, the origin of that? Or is it possible that there is even life on the planet today, probably in the subsurface, buried a few meters below, where it's protected from the radiation that otherwise would get absorbed by a thicker atmosphere? So there's plenty of reasons to think that Mars might be this abode of life. We talk about habitability, and the Curiosity rover in Gale Crater has measured the essential elements of life, and we know there's ice, so there is water in places. But the question is it inhabited? And that we don't know, and so we still search.
Well, if you've just joined us, I'm talking with Dr. Rich Zurek, who is the chief of the Mars Exploration Program at Jet Propulsion Lab. So he's the guy to ask the question that I know I get asked all the time, and I'm going to do it to you. I'm sorry, I'm going to ask you, but do you think there's life on Mars?
It's a different life, if that would have to be there today, because we don't see anything on the surface itself. We can see from orbit, we can see the tracks of the Opportunity and Curiosity rovers, and we haven't seen any sign of something that we would confidently say is an artificial structure. So if there's life, it's microbial, and it's most likely in the subsurface. So where do we go look? Well, there are certain places on Mars that are sort of just very mysterious in the effect that the albedo changes, and we're not sure why. Maybe there's a little bit of water that wets it occasionally. And so those may be spots where we eventually go and dig down and look for that life, or find some other way to look at. And one way that we're looking now is to look at the trace gases in the atmosphere. On Earth, most of the methane in our atmosphere actually comes from living organisms. Now, there are other processes, mineral transformations, that can produce it too, but go look for those trace gases And if we could find a source, then we could go digging.
Yeah.
And that would be a guide star for a future mission to go.
So we've had all these wonderful missions. We had the flybys, the orbiters, the landers, the rovers, and we're about to have InSight, something that's going to dig down about 16 feet. That thermal probe is going to go in. Am I about right on that?
That's
yeah.
right.
So we're even getting inside the surface of Mars. So what's next? We've got this amazing set of spacecraft. We have learned so much. As you said, we've learned that there was liquid water in the past. There's water in other phases there now. It has the right elements for life.
Mm-hmm.
It certainly has the energy source. So what's next to discover, and what's NASA going to do in the next couple of years?
Well, when you think about all the experiments you'd like to do in looking for life, that's not an easy thing in an environment we're not really sure what all the elements and what it's like. So instead of trying to take our most sophisticated instruments to Mars, why don't we bring a piece of Mars back to Earth, where we can analyze it in the very best laboratories that we have. And not only that, but when you get a surprise, a discovery, you can design a new instrument. You don't have to wait to build another mission that flies out to the planet and then eventually does that experiment. You can do it because you have the sample right there in the lab.
So we're going to send a couple astronauts with shovels and a pail. Is that the plan?
Well, we thought first we'd send a robot, make sure that we could return the samples from Mars before we try to return humans from Mars. Seemed like a better part of things to do. And this would be the first time, actually, that we're going to send another rover that's built on the same kind of robotic chassis as the Curiosity rover. So we're taking advantage of all the technology that went into developing that.
And is it going to land in that same way, that crazy sky crane, and it
is
drops
gonna
it
put
down?
right down there on the surface.
Yeah, we have a video of that we'll be showing a little bit
Very
later when we talk
gently.
about Curiosity.
That's one of the great things about the space program draws out that kind of innovation. Because the first time somebody described that to me, I said, no, that can't be right. You wouldn't hover and try to lower something.
What maniac came up with that?
Exactly. But it actually solved a number of problems. And it's a platform that we can actually land that rover, or a landing platform, and that platform will have an ascent vehicle on it. And that ascent vehicle will eventually be the one that takes those samples back into orbit. So first, we've got a rover that's going to land just like MSL did. It's going to rove across the surface. It's going to take samples, maybe as many as 20 to 40 of these samples, and then some of those will be selected for a return to Earth. Second mission will land. We're still working out some of the details of that. Maybe we'll use the sky crane system. Maybe we'll use something more like the Viking spacecraft, where they just land on the thrusters all the way down to the ground.
Yeah.
That will carry an ascent vehicle, and we'll be launching from the surface of another planet for the first time.
Kind of
We've
like
done
we
it from
did
the
when we
moon.
went to the moon. Yeah, exactly. Yeah.
But now we'll do it from a different planet
Yeah.
out there in the solar system.
So exciting. And not too far in the distant future?
We're hoping that we might be able to, so the rover that will we'll get the samples and drill those out of the rock and such, that will go in 2020, land in 2021, and we could get this fetch rover and this ascent vehicle down on the surface in 2026 if we decide that's where we're going to go.
That's
and go
cool.
forward with it in that time frame.
Less than a decade from now, we might be doing that.
So,
And I like the name Fetch Rover. That gets all kinds of ideas flowing.
Now, we're talking with our international partners because, as you've noticed, Mars has become an international destination. Of the 6 orbiters that are there now, 3 of them are actually from other countries. 1 from India, 2 from the European Space Agency and its collaborating nations. So this has become a destination for international efforts. And when you have these various missions that are needed to get the samples all the way back to the Earth safely, then a little help from our partners will be good.
Rich, it's been really wonderful to have you here tonight. Have you had a chance to look through a telescope yet?
I have.
Oh, good.
But I saw Jupiter. I want to see Mars, so I'm going to go
Okay.
take another look.
Well, Jupiter looks beautiful. You can see the red spot, I'm told, tonight. But we want to thank once again Rich Zurek for being with us from NASA's Jet Propulsion Lab, the chief of the Mars Exploration Program.